Okay, here are the solutions for the makeup review sheet for the prob stats test. This is our final, last prob stats thing. Seems like we've been doing this forever. Here we go. If you are dealt 6 cards, find the probability of getting exactly 2 diamonds. So first of all, we're being dealt 6 cards, which automatically means our denominator will be 52C6. If we were being dealt 4 cards, it would be 52C4. The denominator is the total. Now we want 2 diamonds. Exactly 2 diamonds. Now there are 13 diamonds and I'm going to pick 2 of them. However, I must pick 4 more cards. This is a 6-card hand. 2 are diamonds and multiply. 4 of them are not diamonds. So remember, the deck of cards is divided up into 4 suits. So a fourth of 52, or 13 of the cards are diamonds. The other 39, 3 sets of 13, are not diamonds. So we'll type this in on our calculators. And I got 0.3151 if I round it off to 4 decimal places, which is how I have typically been doing it. Sometimes it'll change to a fraction or come out in a fraction, and that's perfectly okay if that's the way you want to do it. All right, question number 2. If you read the question, there are 2 things happening in the problem. We have school or we don't have school, and I'm on my computer or I'm not on my computer. So since the question is, find the probability that I'm not on the computer, that computer part of the problem is the second phase. The first phase of the problem is we have school, we have no school. Now, we have school 4 of 7 days, so 4/7 of the time we have school, and 3/7 of the time then we don't have school. So that's stage 1. Then stage 2 is I'm on my computer or I'm not on my computer. I'm on my computer or I'm not on my computer. Okay? Now, let's see, what are the numbers? If we have school, there's a 73% chance I'm on the computer, which means there's a 27% chance I'm not. Those have to add up to 1. And if we don't have school, there's a 52% chance, which means there's a 48% chance I won't. Now, remember, whatever the question is, that's the last piece of the tree diagram. So in this case, I had to start with school or no school, and then from there, I built the computer or not. Okay, so now I need to know the probability I'm not on the computer. So I need to know this and this. So to get this one, I'm going to take 4/7, so 4 divided by 7, 4 divided by 7, times 0.27. And that's going to give me 0.1543. And then I will do this piece, which is 3 divided by 7 times 0.48, which is 0.2057. And then I will add those 2 numbers together because it's either school and no computer, or no school and no computer. So I'm going to add those 2 together. Oh, and I typed it in wrong. There we go. And I got 0.36. So the answer to the problem is 0.36. Okay. Next, we got kids in a club. We have 60 of them all together. And these kids either like math, and there's 23 of them, or they like science, or they like English. And there are 27 sciences and 25 Englishes. Okay? 7 like all 3. 5 like only math. 10 like only science. And 9 like only English. We're going to pick a kid at random and then find the probability. Okay, so whatever A and B, the denominator is going to be 60 because we're picking a kid at random and there are 60 of them. So now we need to figure out what all the rest of these things are. All right, so here we go. I know that in the M circle, x plus y plus 12 has to equal 23, which means x plus y equals 11 if I subtract 12 from both sides. There's the 12. X plus z plus 17 has to equal 27, so x plus z must equal 10. And finally, y plus z plus 16 must equal 25, so y plus z equals 9. Now you can solve this lots of different ways, but the way we have always done it is looking at these two right here. We've multiplied through by a negative and added. So y minus z equals 1, and y plus z equals 9. So 2y equals 10, and y must equal 5. So this guy right here must be 5. So I add these two together, wiping out the x's, so y minus z equals 1. Combine it with the last equation, y plus z equals 9. Just add them together, the z's cancel out. Now, once I know this is 5, look, 5 and 5, that's 10, that's 17. So I have 17, but I'm supposed to have 23, so x has to be 6. Now I have 13, 23, but I'm supposed to have 27, so z must be 4. And then my double check is, that's 11, 9, 25, which is exactly what I'm supposed to have. Perfect. Now, what do all those add up to? All these numbers here, all these numbers inside the circles, what do they add up to? According to my arithmetic, they add up to 46. Well, if they add up to 46, but they're supposed to be 60 kids, then there must be 14 out here that don't like any of those subjects. Because these numbers, if I added right, these all add up to 46. And I'm supposed to have 60. Okay. So the question is, I want to pick a kid that only likes math and English. So the ones that only like math and English are right here. So that's 5 out of 60, which reduces to 1/12. So the answer is 1/12. And then B says, find the probability of choosing a student who doesn't like any of it. So that would be 14 over 60, which reduces to 7 over 30. So that one is 7 over 30. Okay. Now we're ready for number 4. Number 4 says we've got freshmen and sophomores and boys and girls and 21, 28, 25, 27. Okay, so our school, this is the way our school shakes out. We want to pick one, reach into the pile and pick one. What's the probability of choosing a girl? Well, the girls are right here. So altogether, there are 52 girls. Well, how many kids are there altogether? Well, let's see. There's 21 and 25 and 28 and 27. There's 101 altogether, so the probability of getting a girl is 52 over 101. Because there's 101 kids in this box. Now, what if we had 2,500? How many freshman boys would you expect to find? Well, in my chart, where are the freshman boys? Right here are the freshman boys. So in my chart, 21 out of 101, there's 101 kids here, 21 of them are freshman boys. Freshman boys. So I need to take 21 over 101 and multiply it by 2,500. Now, I will round this off to 520 because it actually comes out to be 519.8, but I can't have 0.8 of a boy, so I'm going to make it 520. All right, there are 32 kids in resource. Five of them signed out and left. 19 are listening to music. 20 are playing ping pong. So I got the music kids and the ping pong kids and 5 kids that are gone. They're out of the mix. So there are only 27 kids left doing the activities. There are 27 students doing the activities because there were 32 and 5 left. But according to my vote counts over here, there are 39 activities happening. Well, if there are only 27 kids to do 39 activities, then 12 of them are doing both because there are 12 extra activities happening. That means 7 kids are here because that has to be 19, and 8 kids are here because that has to be 20. And sure enough, 8 plus 12 is 20, plus 7 is 27, plus 5 is 32. So there it is. That's how it shakes out. How many students are doing both? 12. So the answer to A is 12. There are 12 kids doing both. If we pick a student at random, this is going to be a probability question. What is the probability that he is doing just one thing? So in other words, what's the probability he's either just listening to music or just playing ping pong? It has 15 of those kids. So 15 over 32. Okay. Now we've got a couple circles again. And we have D and E. And we know the probability of D is 0.6. The probability of E is 0.5. And the probability of D and E is 0.3. So that goes right here. The minute I put that right there, I know this has to be 0.3 because the whole D ball has to add up to 0.6. And I know this has to be 0.2 because the whole E ball has to add up to 0.5. So then the question says, what's the probability of not E? Well, this is E. So the answer to the question is everything that's not shaded. Well, not shaded, because E is shaded. So this means not shaded, not E. So if I'm looking at not E, it would be this part and the outside. Well, let's see, 0.3, 0.3, 0.2, that adds up to 0.8. So we have 0.2 out here. So the answer is 0.5. And quite honestly, guys, if you had your thinking caps on, that's a really easy problem. Because if the probability of liking eggs is 0.5, then what's the probability you don't like eggs? 0.5, because they have to add up to 1. If the probability you like donuts is 0.6, then the probability that you don't like donuts would have to be 0.4. So you could figure that out without even drawing a picture, actually, this time. So the answer is 0.5. That was extra. 0.5. Okay, last one. We got a couple of boxes of marbles. They're blue, green, yellow, and pink. And actually, this problem only involves yellow and green, so I'm not even going to put all the numbers in. I'm only going to put in the ones I need, which are the yellow and green numbers. Okay? So I have to pick one from each bag, and I want to get a yellow and a green. I want to get a yellow and a green. So I can get a yellow from the first bag and a green from the second bag. So that would be 0.09. Yellow from the first bag and times green from the second bag. Or I could get green from the first bag and yellow from the second bag. I just have to get one of each. I have to get a green one and a yellow one. So I can do it this way, or I can do it this way, which means I'm going to add them up, and the answer to the question is 0.17. We need to get green and yellow, or yellow and green. And that's it. Hope you did well.